Hello everyone, we are from Group 2 and the title of our project is Atmospheric Air Quality Monitoring. This is the content of our report which consists of introduction, problem statement, objective, and contour, and introduction of literature review, related previous project study, comparison of related previous project study, related review findings with project, introduction of methodology, system block diagram, system flowchart, 3D layout diagram, circuit wiring diagram, hardware and software list, bill of materials, simulation result, which consists of table and graph, method discussion based on the simulation result, what tests and the goals will be done, project hardware pictures, project result, project analysis and improvement, project simulation result, and result analysis comparison, result and analysis discussion, conclusion, and the impact on social, environmental, and economic sustainability, recommendation and suggestion for improvement, reference, and appendix. So for the chapter 1, which is introduction, one of the most important components in the environment is air. Air, which consists of oxygen, carbon monoxide, and traces of several rare elements, fill the air of atmosphere. Humans require a contaminant-free environment in order for them to live. This is extremely important for human survival and wellness. So the goal of this project is to develop and build a smart and atmospheric air analysis system. It explains how to use an Arduino microcontroller and gas sensor to monitor the number of contaminants in the air. The primary goal of this project is to develop a smart air pollution monitoring system which can detect pollution hotspots caused by traffic congestion or industry emission. And for the problem statement, air pollution can cause both short-term and long-term effects on health, and many people are concerned about the pollution in the air that breathe. Other than that, people with heart and lung condition, other breathing problems, whose health may easily be affected by air pollution. And lastly, bad air quality or pollution can impact climate change, which is potentially in increasing the risk of illness through increasing temperature, more frequent heavy rains, and runoff. The objective of our project is to design an atmospheric air monitoring website to monitor the quality of atmospheric air, to develop a solution for health issues that occurs due to poor quality of atmospheric air, to test the accuracy of atmospheric monitoring when it is used to detect the reading of air quality index. So this is our current chart, which consists of all the weekly tasks throughout the semester.
One of the most pressing environmental issues of our day is the quality of atmospheric air in many places throughout the world. So in this project we have learned the importance of air quality monitoring to human and nature. In this project we are going to design and construct a smart atmospheric air quality monitoring. This is going to be used by using an Arduino microcontroller and gas sensor. So this is to doing a literature review for the previous project that is going to be related to our current project. So this is the related previous study. The air quality monitoring system using MQ135 and MQ7, which going to help easily monitoring the air quality. And then next is the mobile air quality monitoring developed by ISIS network embed system, which consists of car-mounted sensor nodes that measure various contaminants in various areas. And then the implementation of portable outdoor air quality measurement system using Arduino. This project created and constructed an Arduino-based outdoor air quality assessment device that can estimate the API value on any site. And then air quality sensing and monitoring, using low-cost solar-powered quality monitoring system based on Zigbee wireless network system to assist school in smart city, which determine the air exposure which is harmful to the school children. Next is the comparison related to the previous study. Based on this researcher, C.S. Saikumar, their project is to monitor the air emissions in industrial urban areas. Proposed outline includes a set of gas sensors, which is CO2 and NO2. that is positioned on mass and structured on IoT, and a dominant server to support both short-range real-time incident management and continuing deliberate planning. Next project is their main objective is to monitor air quality in home areas such as kitchen. This project does not use IoT, but it is using WSN because the purpose of this project is to monitor air quality and display the data through LCD display. Next, based on Catrick, Karesh Muni, and the others, the project is to use three sensors to measure the weather environment factors such as temperature, humidity, light intensity, the dew point, and heat index. For this project, to measure air quality sensor, they use MQ135 so that they can detect the level of NH3, alcohol, benzene, and CO2. So to relate this literature review finding with this project, based on the finding of few papers from past years, the development of air quality monitoring system has become so advanced that they have used more high technology, such as the PLC and electronic wiring, to get a cheaper alternative. So in this project, the common component that same with our project is going to be the Arduino Uno and the MQ135. Thank you.
Hello, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Engku Muhammad Syahkini bin Engku Muhammad Bunia, and I have been assigned by my group to explain to you guys about the methodology for the atmospheric air quality monitoring system, which is the chapter 3. In the methodology, I will explain to you guys how does the project was developed from scratch. And then for the introduction, there is nothing to be explained, but there is a few past projects that have been done as a revision by our group. And then for the hardware and software list, we are using the Arduino Uno which act as a microcontroller, MQ135 for the input, LCD 6 by 2 buzzer LED for the output, jumper wire to connect the circuit, and then the electronic project box, which have been used as the casing. And then for the software list, we have used the AutoCAD for the 3D prototype, and then the Proteus 8 Professional for the circuit development, and then the Arduino IDE for the codes for microcontroller. And then this is the system block diagram. This program or system will detect the butane, and then which is the alcohol, and then when the element of butane is exists, and then it will trigger the MQ135 will act as a input, and then MQ135 will send the signal to the Arduino Uno, which act as a microcontroller, and then it will send the output to the LCD, buzzer, and LED, which act as the output. And then this is the system flow chart. First of all, when the code started, it will define pins and direction for the LCD, LED, buzzer, and MQ135, and then we can set the threshold for air quality, which is if it is more than 150, it will trigger the microcontroller, and then if it is not, then it will the output will turn off. We can see right here is ppm is more than the threshold. If yes, it will display air quality level is high, and it will turn on the LED and the buzzer. And then if the ppm is not is less than the threshold, and then it will display air quality level is good, and it will turn off the LED and buzzer. And then this is the circuit wiring diagram. We have used the Proteus 8 Professional to develop this circuit. There is a few resistor and capacitor which act to protect the circuit from overcharge. And then there is a few, we can see right here, the pins that is connected to the output and the input. And then this is program coding. The instance of the explanation, it will be explained in the report writing. But these program codes have been inserted into the microcontroller, thus it will execute the program that have been set. And then this is 3D layout design. The 3D layout design was developed by using the AutoCAD. And then this is for the LCD for the MQ135 right here, and then this right here for the LED and the buzzer. And then this is the bill of materials. As you can see right here, it is only the total is 98 ringgit and 30 cents. So the project has achieved its old objective, which is we have produced or developed a much way cheaper and or affordable air quality monitoring system for the market. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Zaini Rosman. I will explain about our project hardware for air quality monitoring. So these are our project or hardware of our prototype. And then I will explain about the main issue that encountered in this project was that the LED and buzzer did not function as expected. So we do some troubleshoot to detect the problem. So first of all, we check the terminal for both components, LED and buzzer. Then we also check the connection between terminal LED and buzzer with pin at Arduino Uno, and also double check the number of pin for the LED and buzzer at our coding in Arduino IDE. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Muhammad Syahdan bin Tuampa. I will be continue to chapter 4. Okay, this is our project simulation result comparison chapter 3 and chapter 4. As we know, chapter 3 we have no capacitor and inductor in MQ135, and chapter 4 has capacitor and inductor. So this is our result analysis. We have two conditions, which is AQ level below 250 and AQ level greater than 250. That's all to me. Thanks.
For the simulation test result, based on the simulation test result using Proteus software, the circuit has been working very well. The LCD managed to display the outputs based on the programming system, and the buzzer functioned very well according to the program that has been embedded into the system, and the sensor able to detect smoke, heat, and alcohol. For the actual test result, the LCD was able to display the outputs according to the system programming. From that, the MQ135 sensor is capable of detecting heat and alcohol but not smoke. Furthermore, when the MQ135 sensor detects heat, the buzzer effectively produces a loud noise that may be utilized as a heat indication. And as a result, this project is capable of detecting any type of dangerous gas, and it is regarded as a success.
So moving on to the discussion and comparison of the simulation and actual test result. So the simulation result for MQ135 able to detect smoke, heat and alcohol, but the test result only detect the alcohol. But the buzzer and LCD function very well, which display the output and also alarm the user. Next is the discussion and hardware of the software and hardware development. To design the prototype, we use AutoCAD, and the box has been modified by using an LCD, buzzer, and LED, and the MQ135. The sensor is put outside so it can effectively detect smoke and heat and alcohol. Lastly, the buzzer and LED is put outside so that it can alert the user and can be seen clearly uh, by the LED brights up. In developing the project, students have used Proteus, Arduino, and AutoCAD. AutoCAD is used to design the hardware, and Proteus is used to design and simulate the circuit. Lastly, the Arduino Uno is used to control the MQ135.
Next, we go through for the conclusion. The purpose of this project was to find the best solution to detect air pollutants. The project was to develop a machine which is able to help in improving monitoring of air quality. The project has been developed was called atmospheric air quality monitoring. with a smart atmospheric analyzer system that can comprise gases such as nitrogen, oxygen, carbon monoxide, and several rare elements that fill the Earth's atmosphere. For the achievement of all objectives and scope. This project did not meet some objective and scope. Even after some troubleshooting, a student failed to find the error. This prototype detects butane gas that have been attached from the lighter. It can alert the surrounding of the presence of the butane gas that may easily ignite if there is no awareness toward the user. For the limitation of the research, this test was carried out in this study employing a variety of gas, including oxygen, carbon monoxide, ammonia, and other dangerous gas and smoke. As a consequence, the findings demonstrate that the research restriction, which is the sensor limit, which is only works when the gas comes close to the sensor. For the impact on social, environmental, and economic sustainability. For the environmental aspect, the air quality monitoring is environmental friendly as it doesn't release any dangerous substance to the nature. This prototype is low cost maintenance and also user friendly because everyone can use it. For last but not least, for the recommendation for the future research, one of the recommendation for this project is by adding more sensor. More sensor means it continuously monitors indoor air quality so that data can be collected easily and more faster. That's all from our group 2 and thank you for watching.